Hello friends, welcome to my YouTube channel and the series of of theory of computation. So in previous session we have gone through the contents to the introduction to finite automata and what are the different types of FA. Now today we are going to start with the DFA, that is deterministic finite automata, which is the first type of finite automata, and we'll see some examples over here. So the contents are introduction to that DFA, the definition of the DFA, and examples like string ending with. So there are some categories like string starting with, string ending with, and substring type. So from which we are going to cover one category, that is string ending with. So we know that basically there are the two types of finite automata, deterministic and non-deterministic automata. In deterministic finite automata, the word deterministic stands here that our transition is deterministic, means there is only one state to which our machine can move for the current input symbol to the next state. That's why it's known as a deterministic finite automata. We can easily determine for a current input symbol which will be a next available state. And the word finite stands here that number of steps will going to be a finite when we are processing the string over here. So talking about the definition, in TOC, in theory of computation, we are writing the definition of every machine in the form of tuples. So if we talk about the definition of DFA, it contains the 5 tuples. The tuples are also mentioned: Q, summation, delta, Q0, F. Here M stands for the machine DFA. Then Q is nothing but set of finite states. Summation, set of finite input symbols. We are also calling them alphabets. We have seen the terms like binary, alphabet, decimal in our previous session. Then delta for the transition function. Q0 is initial state and F stands for the final state. So whenever we are solving any example for this DFA or any kind of machine, very first it is expected to write down the definition first with whatever the states are there, whatever the input symbols are there. So we'll see this also. The meaning of transition function, that how our state will be moved from one state to another state, how our machine is going to be moved. So it will take the two input, current state and the current input symbol, and what will be the output? It will give you the next state as an output. So let's start with the first example, which is example for the end with. Here we are ending with the string should be ended with 101 strictly, right? So what it means that if our string should end with 101, means before that any combination of zeros and ones are accepted. Anything we can take before the 101, which is the combination of zeros and ones, but after there should not be any string. After the 101 there is nothing should be, so that our string will be end with 101. Okay, so whenever we are solving any questions likewise, what we are expected to write, that first you should write down the definition that already I have shown you in terms of 5 tuples. Then your transition diagram. So your definition is going to be complete once your diagram is ready, right? So first you can draw the diagram and then fill out the remaining part of a definition. Then the table is also expected, transition table and the transition function processing. So now we'll see the example that how to draw that DFA for the string end with the 101. So whenever you are solving any question, just find out that which is the minimum possible string. So if you think about this question, so what do you think? Which can be a possible minimum possible string? That the string should end with 101. True possible string. So here 101 itself, right? This is the minimum possible string. String is ending with 101. This is my minimum possible string. So I will draw the DFA for the minimum possible string first. So we are starting with a Q0 is my initial state. Then I will take a 1. I will go toward the next state Q1. Then I will take a next 0. Will move toward the next state Q2. Again we'll take a 1. Will move toward the next state Q3, which will be my final state, accepting state. The string is accepted. So I have read 101 and my string is accepted. But this is not as simple as that. Here you have to think for all the kind of input possibility. Means what? As we are looking it for the deterministic, means you have to determine that for a Q0, if you are taking 1, then where we are move, where we have to move. If Q0 is getting 0, then where we have to move? So this should be, we can easily determine, means for both or all input possibilities, we have to find out that to which state it is moving it for next state by taking a current input symbol, right? So we'll start with the Q0. We have to check both the input possibility for a Q0. So Q0 already done with 1. Now we have to think about 0. If Q0 will get 0, then where it should move. Okay. So we are at initial stage. Nothing is accepted. We have not started yet. And initially, if we get a 0, then what will happen? At Q0, if we get a 0, then what will happen? We are taking the input 0, and after that what we are expecting is 101. So which is the state responsible to generate the 101? Which state is generating 101? We can say Q0 can generate 101. So we have to remains to Q0 when Q0 is getting input 0, means whenever there are the number of zeros, you can accept any number of zeros before the 101. That is what our statement is. Here we can accept anything, but here it is not allowed to accept anything, right? So before 101 we can take any number of zeros. That's totally fine. So we can see here Q0 done with 0 and 1 here. Now moving forward, we have to think about the Qn. So for a Qn, very first think how we are coming to Q1. We are coming to Q1 by taking number of zeros and 1. This self loop says that you can take 0 or 1 or 2, means 0 or more zeros. Okay, 0 number of zeros or more number of zeros. So whenever I am assuming, I always assume the minimum possible. So how I am coming to Q1? By just assuming that we are taken 1 from Q0 and we are coming to Q1. So by taking 1, you can consider the multiple zeros and then 1 also, but try to keep it as simple as possible. So by taking 1, we are coming to Q1. At Q1, if I get a 0, then fine, will move toward the Q2. But if instead of 0, if I am getting a 1, then what will happen? So if I am getting a 1, my string should be end with a 101. So 1 is already there. What is expected thing is 01 should be there. And which state is responsible to generate the 01? We can see here. Which state is generating 01? Q1, right? So what we have to say, we should move towards Q1 if I am getting 1 at a state Q1. Means again there will be a self loop of 1, means remains in Q1 itself if you are getting the number of ones. Keep it as it is, right? Then Q1 is done with 1 and 0 both. Now we have to think about Q2. How we are coming to Q2? First write that. How we are coming to Q2? At a Q2, we are coming by taking 1 and 0. We are coming to Q2 by taking 1 and 0, which is compulsory we have to take. And after this 1 and 0, we are expected to take a number of things like if Q2 will have the 1, it will move to Q3. But if Q2 will have a single 0, then what will happen? So instead of 1, if it takes 0, then what will happen? So after this 100, the whole 101 is expected, right? This is not acceptable. After that, the whole 101 is required. So from where we can get this 101? We can get it from Q1. The Q1 is a state which is responsible to generate this 101, right? So we have to move to Q1 once Q2 will get 0. So we have to move to Q0 by taking a 1. Here, sorry, if it's take the 0, then we have to move to Q0, so that it can again take 101 and the string is going to be end with the 101, right? Now Q0 is done with 0 and 1. Now we have to think about the Q3. What will happen? We need to think about Q3 because after taking a 101, we are coming to Q3. But after this, nothing is expected, right? So we should not accept anything after 101. So let's see what happen if our string is more than 101. So definitely 101, and we can also have 101 again, right? So the string can be greater than the 101, so we have to think about that. So let's see, we are coming to Q3 by taking 101. After that, if I am getting 0, then what is expected? That we have a 0, before that we have a 1, means 10 is already there. There is a need of only 1, which is the state responsible to generate the 1 which is near to Q3, that is Q2. So what is expected is that we should move towards Q2, right? So here we have to move towards Q2 if we are getting 0. Fine. Now next, We are coming to Q3 by taking 1, 0, 1. But instead of 0, now if I am getting 1, then what is expected? Means 1 is already there and we should end it with 0, 1. So 0, 1 is expected over here. So which is the state responsible to generate the 0, 1? So definitely the state Q1 is there. So we should move towards the Q1 from a Q3 when if it is get a 1 as a input. And here Q3 is also done with 0, 1. So just check all of the states are done with all the kind of possibilities of input. So here two possibilities are 1. So Q0 done with 0, 1, Q1 done with 0, 1, Q2 done with 0 and 1, Q3 done with 0 and 1. So our DFA is ready now. What we have to do is once our DFA is ready, so I kept it here ready and just complete your definition. So first write down all the parameters of definition and just complete it by filling the remaining parts, like what are the set of finite states we have. So Q0, Q1, Q2 and Q3. So Q3 is a final state which is shown as a double circle. Q0 is a starting state which is shown as an arrow. Input symbol. So two inputs are here, binary input 0 and 1. Transition function we are going to see it later. Then Q0 is my initial state. So Q0 will belongs to number of state Q, and final state is Q3. We can have the multiple final states, so that we have to mention here as a subset. So Q3 is a subset of Q. We can write likewise. Q3 is my final state. Q0 is my initial state. So here definition is completed. Our transition diagram is also ready. So definition is ready. Second thing, a diagram, transition diagram. And now we have to draw the transition table also. It's very simple. Just looking at a diagram, you can easily build a transition table. Vertically, you have to write down the number of states, that is whatever is mentioned in your diagram, Q0, Q1, Q2 and Q3, where Q0 is initial state, show like this, Q3 is a final state, show like a star. Okay, and horizontally you have to write down input 0 and 1. Now what is the next step? We have to consider this Q0. If Q0 is getting 0, where we have to move Q0. If Q0 is getting 1, where we have to move at a Q1, right? If Q1 is getting 0, then we have to move to Q2. If Q2 is getting Q1 is getting 1, then we are remaining in this state Q1 itself. Here it is again, Q0 with a 1, it's a Q1. Okay, then Q2 with a 0, where we have to move Q2 with a 0, we have to move to Q0. Q2 with a 1, Q3. Q3 with a 0, Q2, and Q3 with a 1, Q1. So transition table is ready. Now we have to consider fourth is nothing but transition function. So for that, just assume any string which is a string ending with the 101. So I'm assuming 10101. This is my string. Okay, so let's process it by using a transition function delta. I have already told you there are the two inputs to the transition function. Current state, which is my current state, Q0. Then current input symbol is 1. This is my first input symbol. So Q0 with 1, where we are moving. You can either refer a diagram or refer a table, doesn't matter. Okay, so Q0 with Q0 with 1, where we are moving. Q0 with 1, we are moving to Q1. Now Q1 becomes my current state. So we are at now Q1 and we are getting the input symbol, next input symbol 0. So Q1 with the 0, where we have to move towards Q2. Delta with Q2. Now Q2 is my current state, next input symbol is 1, we have to take that. Q2 with 1, where we are moving Q3. We reach to final state, but still our string is not finished, right? So we have to process all of them. So now Q3 will be there. Next input, it will be a 0. Q3 with 0, Q3 with 0, we have to move towards Q2. Then Q2 is there and last one symbol is there, that is 1. And Q2 with 1, we can see that Q3. So my string is end as well as I have arrived to the final state Q3, means the string is accepted successfully, which is ending with a 101. So this is the way you have to show the transition function, transition table, transition diagram, and in previous slide we have looked for the definition of the DFA. So this is the way you should answer to the question, and here we have shown the string processing and the example of end with. So for the exercise, you just try to be consider the string which is ending with AAB, a string end with AAB. You just try for it as an exercise. The task is given to you. You can complete it. So with that, we'll stop here. Keep watching. In the next session, we'll have example of start with and the substring. Thank you so much. Keep watching.